welcome everyone to our first MLPsych Consortium Worldwide Lab meeting. I'm very glad to see everyone here. As I said, we're starting sharpish. We'll try to keep that up. So please try to hold questions until the end, just so the speaker can have time to finish. And so I am very pleased and honored to introduce Dr. Rafael Geurgas. Oh God, now I've butchered it.
Geurgas, that's fine.
Geurg-
Everyone got it out.
Sorry.
That's fine.
From Purdue University, and the title of his talk is What Machine Learning Teaches Us About Depression Prediction Across the Life Course, an exploratory comparison of prediction models. So I'm going to hand it over to you, Rafael.
Okay, so I think you can hear me and I think you can see the screen, right?
Yes.
Okay. Okay, so hi everyone. My name is Rafael, and I'm going to talk about today a little project that I've been developed at Purdue University that it was a paper that we published last year. Okay, so let's first talk about the research question that we're interested in. So can we use information collected in adulthood to predict depression? Can we collect information collected during adolescence to predict depression in adulthood? And for that, we can split our project in three different steps. First, we're going to collect information in adolescence using health data. And then we're going to train and adjust 5 different machine learning models in the information collected during adolescence. And why 5? Basically, we wanted to test a benchmark model that is widely used in the social science, that is the logistic regression, against more sophisticated machine learning models. So we have decision trees, support vector machine, SGBoost, and even a deep learning model, neural networks. So we got a spread of different complexity levels. And finally, we do everything this for predicting the data behavior in adolescence and also in adulthood. So this is a basically overview of the project that we had. Okay, so let's talk about the data set. So health is a longitudinal study. That means it's collect information at multiple time points in their life. They start as young age of 12 and during adolescence, and then goes all the way to 40, 42 years old, late time, but basically full adult. And for us, we are interested in wave 1 that is collected during the adolescence and wave 4 that is during adulthood. And in wave 1, we're going to train. So everything that is trained in wave 1. And also, if you are doing some adolescence type prediction, we are going to also use the wave 1 as a predictor. And then we also use the wave 4 as a predictor to adulthood. So wave 4 is roughly 20 years later. So we're going to have 20 years later between training and predicting for adulthood. Okay, so we are going to talk about the inputs data. So what is the theoretical predictors that we are including in our data? We have basically around 100 variables. It slightly differs between females and males because sometimes for health data, they ask some female-specific data. So this is like this slight difference. And here, I think it is a good way to, good thing to notice is that we have a slightly different language between social science, more like sociology, and psychology and psychiatry. Here, we're talking about environmental data, everything that is not polygenic. And I know it's like a big group and you have a lot of nuance that, but this is something that people does in the field. So I'm just keeping simple. I not 100% agree with that, but let's go. Okay, so on the left, we have a few noticeable environmental examples like income, forced sex, sex with drugs or money, if the person feel loved and wanted, general health related questions. And on the right, we have polygenic scores that are typically correlated with depression, like alcohol dependence, PTSD, bipolar, even the major depressive disorder, well-being. So we're trying to include as many variables as we fit that is slightly relation to depression. Those are not the only ones. We have a full description in the paper if you are interested. So we have 76 environmental ones and 21 polygon scores. So we try to be as broad as possible in this. Okay, so we talk about the input data, and let's talk about the output data. So AdHealth collect the CD scale
Rafael,
depression.
sorry.
Oh.
Can I raised my hand, but maybe you didn't see.
I cannot see it. Sorry.
You're locked in, and that's great. But could you go back one slide?
Oh, sure.
So there's a different number of polygenic scores for males and females, I presume, because like maybe age at menarche is one for females that isn't used for males. But it's an interesting question in that you could use age at menarche PRS as kind of like a dummy variable for males, almost as like a negative control. Any consideration of that? It shouldn't have any relationship in males to anything.
Oh, yeah. So basically what we did is that we did for only females and only males, and then we combined for both of them. So in the both data set, we basically have a dummy variable for men's when you combine everything. Okay.
Okay.
As you can see,
yeah.
Not going to spoil anything, but you're going to see. I can circle back that when I arrive there.
Thank you.
Okay. So basically, this is the outputs that were interesting. So the CDs scale. And in wave 1, they ask the full 19 questions for depression. And then wave 10, they do the reduced scale version that is only 10. So we sum all the information, and then we use the recommended threshold to have a lower depressive symptoms and a higher depressive symptoms. So we have a binary outcome. And then this is what I do for wave 1 in adolescence and wave 4 in adulthood. And here is basically overview of our project. So we have 3 different inputs. We're going to have only environmental models, only polygenic scores model, and a combination in environmental and polygenic scores. And we're going to feed for 5 different machine learning models, and we're looking for 4 different outputs. We're going to look into adolescence. We're going to see the depressive symptoms, the CD scale. We're going to also compare with clinical depression. And we're going to do the same thing, but now 20 years later in adulthood. We're going to see the depressive symptoms and the clinical depression. And for that, we're going to stratify by sex. So we're going to have males models, only female models, and both sex. So if you combine the number of possibilities, it's more than 100 different possibilities. And then we're going to try to sum it up in 10 minutes. And just a disclaimer, since AdHealth is a longitudinal cohort, that means that sometimes people drop between waves. So we try to be as broad as we can, try to retain as much information that we can. But if we're talking about wave 4, we're going to only use the people that agree to continue the study in wave 4. What is the laser? And then if we're going to talk about polygenic scores, only 1/4 for the people agree to give the genetic information. So just keep in mind that we have this problem. Okay, so let's talk about the results. So here it's an overview of everything that we got from the different models. So let me help you understand this bar plot. So first, on the bright colors in green, we have both females and males. And then we have, in lighter colors, we have also for wave 4. And also the bright colors are wave 1 and the light colors are wave 4. And now that I realize that I got a little thing, I forgot to put the names. So just go to the paper and then you can see that this first one is the logistic regression. This one is decision tree. This one is support vector machine. This one is also support vector machine because we did twice, one for the linear kernel and this one for the RBF kernel. This is for this SGBoost, and this one is the neural network. Sorry, I think I missed when I was printing, but you go to the paper and you can see the whole thing. And okay, so the first thing that we can see is that the difference between adolescence and adulthood, you have a sharp drop, and that is super expected because here we are predicting within the same wave. So we're collecting information in wave 1, and also we are predicting in the same wave in wave 1. And here we're collecting information in wave 1, and we are predicting 20 years later. So it is quite impressive that we are still have like 0.65 in area under the curve 20 years later as a predictor. So those are the full models. As you can see, we don't have that much difference between males models, female models, and both sex models. So this is something that they asked me before. And yeah, when we were trying to do some like dummy variables as like a menarche or specific on female questions, you can see that we don't have a difference that much in performance. Okay, so let's take a look in wave 1, both, since they're not that different, models. So if you take a look on both sex models, and we have a highlight in the performance in area under the curve, we can see that SG boost, it's significantly higher than logistic regression, and I agree, it's not that different. It's like 0.02 increase, but it's a significant one against the benchmark model, that is the logistic regression. And if you do the same thing for wave 4, we still have this increase, but now it's a little short, or it's a little lower, and 0.015. So both in wave 4 and wave 1 for depressive symptoms, we have that the machine learning model SGBoost perform better than the statistical model. Yeah, the performance is not that great, not that bigger, but we have some improvement. Okay, so now we detect that the SGBoost is the better model. So let's go back and see what is driving this model to the prediction. So we perform a feature analysis, and we're interested in what is the most important questions that the model figured it out. Okay, so here we're looking for depressive symptoms. In blue, we have wave 1, and in orange, we have for wave 4. So one thing that I found super interesting is that between wave 1, when they're adolescents, and wave 4, when they're adulthood, the questions, the most important questions, at least the top 5, are the same. So the things that matter when they were adolescents still matters when they are adult. That's interesting. And as you can see, those are the highlighted difference between them. And you can see that they're not that different, because here is the reason that they don't get medical care, and here is just a binary that they get or not get medical care. So you can basically say that top 10 most important questions are the same during adolescence and adulthood. And if you take a look, a broader look, and what is the cluster, and I can think more 3 different broader groups between self-perception and how they feel loved and wanted, if they do everything right, family feels, how the family pay attention to you, if they feel socially accepted, how they feel about home. And also we have a cluster on general health, if they are feeling weak or are feeling hot, if they get or not get medical care. And also we have a small cluster, and it is about trouble in students. And I found this super interesting, because if you're looking to adulthood data, they don't go to school anymore, but it is a problem even in adulthood if they had problems during adolescence. So I think this is super interesting. Okay, so this is for depressive symptoms. So we did the same analysis, but now with a clinical depression. So one of the questions in adult health is, have you ever been clinically diagnosed with depression? If yes, when? What is your age? What was your age at the time? So we basically do the same thing, but now with clinical depression. And we have, looking here, we have a major difference, is that things that are important for clinical depression are different for adolescence and adulthood. And if you can see, we have now, if we do the clustering thing again, we can see that now we also had self-perception and general health, but now we have a new cluster that we didn't have when you were talking about depressive symptoms. We have like stressful life events and altering life events. So pregnancy, forced sex, attempted suicide, and someone in the family or friends attempt suicide. So those are stressful and life-altering events, and this appears as an important predictor as a clinical depression, but not as a depressive symptom one. And it makes sense. It agrees with literature that stressful and life-altering events are generally associated with clinical depression. So I found this very interesting that the model was able to capture this nuance. Okay, and if you put like side by side, you can see that things that is important for depressive symptoms are not always important for clinical depression. So actually you only have 3 questions. They're the same, but you have some that are like similar. So that's interesting to notice. And finally, if you look into those questions, you can look and see, okay, I thought you were saying that you were using polygenic scores to make the prediction. And yeah, we are using, but they don't appear in top 15 of any of those, not in adolescents, in wave 1 and wave 4, not for depressive symptoms or clinical depression. So we perform a sensitive analysis to assess the impact of the polygenic scores. So basically, we are using the environmental and polygenic data, that is what we're talking about. And then we use only the environmental data and only the polygenic scores data. So we did the predictor. As you can see, let's start about the green bar. That is only polygenic scores to try to predict the depressive scores, the depressive symptoms. And basically, we have a random predictor. So only polygenic scores are not good to predict depressive symptoms, and it is kind of expected. And this is something that was also kind of expected, is that if you're using only environmental data and environmental data plus polygenic scores, you can see that we basically have the same predictor. So we don't have any significant improvements prediction if you add polygenic scores to the mix. And this is not something particular for wave 1. If you do the same thing for wave 4, we still have the same predictor for them. So we can conclude that at least on this case, adding polygenic scores, we don't have any increase in prediction power. Okay, so let's wrap it up. So basically, the SGBoost perform better than all models. And actually, we have like a marginal but significant gain compared to the benchmark model logistic regression. And when you compare adolescence and adulthood, we have a prediction decline. And when you're looking for most important questions, if you're looking to depressive symptoms, they agree between adolescence and adulthood, and self-perception and general health, or the more important questions. When you take a look on clinical depression, they don't agree between adolescence and adulthood, and trauma appears as a new category that didn't appear in depressive symptoms. And if you add polygenic scores to the mix, we think that it is a limited power and prediction when adding. Even have you remember that we had the major depressive disorder as a polygenic scores there. And in this context, at least, environmental data carry way more predictive power than polygenic scores. And this is basically the project that I worked with last year. And spoilers. And then what is the future for this research? Okay, so to be 100% honest, I thought before starting that the gap between statistical models and the machine learning models got bigger than 0.02. And we thought that one of the major things that could happen is the data size. So if you remember, AdHealth is basically 15K people, like between 20,000 and 15,000 people. That's not much when you're talking about like machine learning, especially if you're talking about deep learning. So our idea is try to recreate this project, but now using all of us data, and all of us is basically at least 10 times bigger. So we're going to have, I think, I'm going to predict that we're going to have a wider gap between statistical and ML problems. And another thing why you use EduHuffs is that they have very similar questions than EduHealth. Okay, so this is my research and was my overall plan for this year. And this is the wonderful people that I collaborate with. And if you want to take a look, this is the QR code for the paper. We just published in Social Science and Medicine paper, Population Health. And also, I want a little, this is my last year here at Purdue. And if you have any postdocs open up that you know about, or you're looking for any postdocs, I'm more than happy to talk about. I'm interested in machine learning and mental health care. So feel free to send me a message or talk to me. Thank you so much for your time.
All right, thank you very much. That was an extremely interesting talk. I have questions, but I will open the floor to others. Does anyone have a question for Rafael?
I had a question.
Oh, hi.
Thanks for the talk. It was really interesting. The decline from adolescence to adulthood, obviously it's something that you expected. It makes a lot of sense. Did you try a model that just took the like predictions from childhood and used those predictions to predict adulthood? And why I'm saying this is like, it seems like it could just be some proxy prediction where it's effectively just still predicting whether someone had depressive symptoms in childhood, and it does slightly worse because some of those cases resolved.
Yeah, I think it is basically this. I think it is. It is something that is like probably is something like left over from the childhood that is not like properly done. So yeah, this idea was basically to check, what happens if we can do, like we can try to see if you have like some prediction power. So it was more like an experiment to see how well we can perform. And to be honest, like 0.65 is not that bad. So it could be a little proxy and help to like clinicians to actually take a look.
Thanks.
Hey, great question. Anyone else? Okay, so now I have questions. So the first question that I'm sure if you know me, you know I'm going to ask is why did you choose decision trees over something like random forest?
So our idea was basically, let's take the simplest model that I could think about it.
Right, okay.
So that's why we use the decision tree. And we basically use random forest for the SG boost.
Oh, right, okay, got it.
Yeah, so I want to see, okay, I want to try both of them. We did this just decision tree to see like how well, and as you can see, this is by far the worst model because we probably got like a bad tree.
Yeah.
And then they say, that's fine. I don't mind at all. Let's go for the SG boost and try to correct the correct way of using decision trees.
Okay, that makes a lot more sense. The decision trees are obviously extremely unstable. So as you said, you probably just got a bad tree. And maybe if you try to get a slightly better one, but you might get a slightly worse one, to be honest. So you never know what you're going to get with just a single tree. The other thing I wanted to mention is that I think this is really interesting work because for so many of the papers that you see in psychiatry, we're using sort of one large cohort, say UK Biobank, and we're taking half of the data, let's say, and we're using that as a training set, and then we're using the other half as the test set. And that doesn't really tell you about predictive ability across the sort of entire lifespan, right? And so I think it's really interesting work because you do have that gap and you can actually show, okay, we have a good prediction when, it's childhood, or adolescence. But then when you're looking at, however many years later, it's not as good, but it's still got some predictive ability that could be relevant. I mean, when you think about a GP, and someone goes in and they say, well, I've been feeling kind of down and I don't have any energy and things that I used to like doing, they're not really that appealing anymore. And when you think about it, GPs might say, okay, well, that's depression just immediately. Or they might be like, well, have you tried exercise? And just leave it at that. So GPs often don't know much about psychiatry. And so these types of models are really important because if we can get them to a point where they are extremely useful, in clinic, they could have on their phone a little app that tells them, okay, so here's a list of questions and here's your predicted risk of depression, and that could lead to better clinical care. Because a lot of people with depression don't see a psychiatrist. They just stay with their GP. So that's why I think this is a really fascinating study, is that you do have that time gap. So I wish you all the best of luck in the All of Us cohort, and I'm really looking forward to seeing that.
May I comment something? So like
Go ahead.
here we didn't have time to talk, but on the paper I describe a little more like, okay, so this is like a theoretical model. No one's gonna ask like 100 questions for a patient,
No.
because especially the polygenic scores. So we got more into details, and okay, this is like theory paper, how we can apply this to a clinic. So like as an extension to the model, if we would to include this in clinic, what is the benchmark, like what is the roadmap? So I didn't have time to get into details, but if you want to go to the paper, we have more like, okay, so we could eliminate the questions that are not that interesting. So if you go to the feature importance, we have questions that are interesting. Then we have like 20, 30 questions that doesn't matter at all, at least for the model. So we can like scrap that. We can scrap the PRS. And so we have more insights on how we can be more clinical useful. I know it's like a long shot and it's not ready for that, but it's like a exercise, like a tough exercise.
Yeah. I mean, I do think at some point we will be ready for that, but I think we're fairly far away from it at the moment. Yeah.
100% agree.
April, I see you have your hand up.
Yes, I'm an assistant professor at University of Southern California. This is my first time to join this meeting, so I'm really glad to hear about this talk. So I have a follow-up question regarding the longitudinal design of the study. So I think depression kind of fluctuate during time, and then it's good that seems like you have an implicit assumption that if someone happen in the adolescent time that they have depressive symptoms, then they have a higher risk in adulthood 20 years ago. So I was wondering if it's possible to get maybe more longitudinal data, maybe 5 years ago, 5 years after adolescent or 10 years after adolescent, so you get some more longitudinal trajectory in terms of the depression. So then you may be able to better predict rather than only 20 years ago of a person at that time if they have depression symptom or not. I don't know if my question is clear.
Oh, I think it is. So let me know if I understand correctly. Basically, so this is the design, the study that we're using for. So fun fact that for the best of my knowledge, EdHealth is collecting a wave 6, and I think it was like 4 years ago, and they're like processing the data. So I think they're completed asking the questions. It just need time for actually compiling and release the new version. So we have something even more like, I think it is around like 50, 60 years old. So we have like a 6th wave coming up. But this is not your question. So I think from what I understand, your question is like, okay, you did for wave 4, that is like roughly 20 years old, but why don't you did for wave 2, that is like 2 years later, or even wave 3, that is like 5, 7 years later? Is that your question?
Yeah, or maybe instead of one time point, have you thought about modeling the depression trajectory instead of just one time point?
Oh, one thing that is that they didn't ask the CD scale for more than a wave 4, if I remember correctly. It was been a time since I looked at other waves, but if I remember correctly, it was only the wave 1 and wave 4 that they had the CD scales. So if you use the wave 2 and wave 3, they have data points, but we don't have the output. If I remember correctly, it's been a while.
Oh,
So
I
that's
see.
why we changed the wave 1 and wave 4.
Okay. And then the other question is, have you thought about predicting the continuous CESD score? Because I think we try to do some type of so I do more like autism research. So we always got reviewer question in terms of try to predict the continuous score versus the binary, because binary could you sometimes just make arbitrary cut off, and then that might introduce a lot of noise as well. And then it seems like you have a lot of power in terms of predicting the continuous score with the 15K sample.
Yeah, so actually, the first attempt was to use instead of like a logistic regression, we do like a logistic, instead of logistic regression, we do like a linear regression. And then instead of using classifier in machine learning, we just like do a regression. This was the first attempt, but we wanted to make it easier, let's say, about this. We didn't want to overcomplicate the project, because a binary classifier is easier to try than a continuous one. So that's why we stayed with the continuous, the binary one instead of the continuous one. But could be an extension. So now we have the model done and everything done. Maybe for when you work with AdHealth, we can do both a binary one and when we work with all of us data, we can do a binary one, and also we can do a continuous one. We just did not do because of time, because
Yeah,
it
I
is
see.
like we gotta have to find like a new 5 different models. I know both of them have the classification, but I have to rewrite the code, so it's basically a time constraint.
Right. Yeah, but I think this can be a natural extension
Yes.
or like the next paper. So
Good suggestion. Yeah. Once we finish the other all of us, we can add this as well. I think it is a good extension. Thank you so much for your question. I agree.
sure. Yeah. All right. Great. Yeah. Great talk.
Thanks.
Sorry, do we have anyone else? Sorry.
I had one more question.
Sure.
For the polygenic risk scores, it's like I'm familiar that it's very hard to get good scores out of them. But these are like exceptionally low. What scoring method did you use, or were you just provided these scores by AdHealth?
Yeah, we provide the scores by AdHealth. So AdHealth, one of the questions, they have the polygenic scores. So I don't know exactly how they collect it, but one thing that we can infer is that they're kind of old.
Right, because it's from when they were collected.
Yes.
Okay.
So we went to the discussion of the paper, like why exactly we can think about the polygenic scores. But if you can see like bipolar, that is like highly correlated with depression, it is like for 2011. So
yeah,
we have some old polygenic scores, so maybe the power is not there.
Right. Well, I assume those are the summary statistics that they use to calculate the polygenic scores. Yes. But it's like it's been shown relatively recently, that these new methods that have been coming out for scoring are significantly better.
Yes.
So I guess I would just say, like, don't completely give up on the polygenic risk scores for the all of us data.
I'm a believer.
Of course, it probably still won't do better in the combined model, but the polygenic risk scores alone will likely do better than you saw here.
Oh yeah. No, jokes aside, I agree. And we got more like details in the discussion of the paper, but I think it is because of the old methods. And when they're releasing, I told you that they're releasing the 6th wave, and I think they're going to release some polygon scores with the newer updated methodology. So maybe for a future research, redo with, but now with like more samples. And also, one thing they didn't say explicitly is that when you were looking for polygon scores, we're only using like 5,000 people. So that's something that also could be related, is that the power is very low when you're talking about only polygon scores, because 5K people is not that much.
Right. Yeah, I suppose it would be interesting to see how well the environmental data do with 5,000 with the same set of people.
Oh, this is, yes, this is for, let me just double check if it is this graph. It's for 5K or not.
Oh, yeah, I guess the combined
5K.
was 5K. Yeah.
Yeah. So everything is for 5Ks, because I remember doing for my paper. I don't remember if this was in the supplemental material, because I did for both. I did like the best score possible and only the 5K to better have more fair comparison.
Right. Thanks.
No problem.
Okay, any further questions? We are running out of time, I'm afraid. So if you have a question, make it short. Right, okay. So I wanted to make another statement about the polygenic. Oh, Steve, go ahead. Oh, you're clapping. I'm sorry. I thought that
That's
was
all. Great job.
Yeah, thank you very much for your talk and for spending time with us. The next talk is on the 13th of February, and there will be 2 speakers with short presentations. Please join us then. And I think I will go ahead and switch to a paid account so we have a little bit more time, because I think we could have used more time today. But Rafael, thank you very much for your speech and for giving us all the very interesting information about depression across the life course. And I will look forward to seeing everyone in a month.
Thank you so much for the opportunity. And if
Right,
you have
thank
any
you.
questions or any suggestions, just send me an email, and here's the link of the paper. Thank you so much.
Okay, thank you.
Bye-bye.
Bye-bye. See you.
See ya.
Bye. Thanks, everyone. I'm just waiting for everyone to leave.
I'm trying to leave.
Oh, okay. Everyone? Anyone?